So again, if solving equations using inverse operations wasn't your cup of tea and you were getting questions wrong, this might be your lifeline. If at the end of today you're like, honestly, miss, I don't like this and I like the old way, cool. You only have to do the box method for me just right now until we go through this, and you can make a decision which way you like better. The very first thing on here is a completely walked through example of how to do this. So in this completely worked out example, I can't show you on my screen all like the steps and the problem. So look at, I'm going to read off the steps that are on the bottom here, but I'm not going to show it to you. So the first step, it doesn't say this, but we are going to draw our line. But look, they already did that. Woohoo! So they drew their line down the center of the equal sign. They didn't have to distribute. If there's any distribution, you still have to do that. That's the original. That's the same thing. So we do 5 times x, which is 5x, and 5 times -4, which is -20. From there, you draw 2 giant boxes. Okay, make them super rectangly, just like they did here. Each box has 2 rows. Okay, they did that for us. Then we ask ourselves the following questions. Look at your questions on your notes. It asks me, how many pieces in my equation have an x in them? I have 1, 2, 3, 4, 5 pieces. How many of those pieces have an x attached to them? 3. So I would go, and on the x side, which is over here, I would make sure there's 3 top boxes. How many pieces don't have an x on them? 2. And that's going to go to the everything else side, which is over here. I make sure there's 2 top boxes. We're already pretty much almost done. The next step tells you to organize your information. This is the drag and drop step. So I'm going to put the pieces where they belong. If the piece has an x attached to it, I'm going to put it on the x side. Oop, that was a highlighter. I'm going to put it on the x side. But when it crosses that center line we drew, what do I have to do? It was positive 5x on this side.
Oh, make it negative.
I do have to reverse the sign. I still have to use inverse operations, but just change the sign. Yeah.
But that one crossed the line, but it didn't change.
Which one? This one?
Yeah.
This right here, it didn't cross the center line. I'm talking about the center line for the crossing the sides, okay? The center line. Now, if I keep going and I put my everything else pieces where they belong, look at this -30. Whoop, it crossed the center line, so it changes signs. The -20 gets to stay over here, doesn't change signs because it didn't cross the center line. From here, all we have to do is add. Add is bolded and underlined on your steps. So across your top, you're just going to add your numbers. What's 2x plus 5x plus -5x? 2x. So then you put the top is the parts, the bottom is the whole. So we put the whole on the bottom. What is positive 30 plus -20? 10, so we put that at the bottom. The last couple steps look very similar. We're going to divide by the coefficient of the x, which is this 2. And I'm going to divide both sides by 2 because I still have to do balanced equations. I still have to do inverse operations. So then I'd have x is equal to 5. That's my solution. This problem would be really complicated if I did this the old inverse operations way. If you like the old inverse operations way, go for it. Okay? We're going to practice probably like 5 or 6 questions today using the box method so that you can make a decision on whether you like this one better or you like the old way to solve. A couple recommendations. When we have a distribution step, like they did on this front page, if you distribute, I want you to write down the entire equation again. A lot of people are trying to distribute in their head and then forget to drag a -20 instead of a -4. Okay, absolutely write this down. My other recommendation is that you actually physically draw the arrows where things are going. Because if you just think you know where it's going, sometimes it crosses the center line and we forget. So physically draw the arrows where it's going as we're doing this. Deal? Deal. All right, let's try one. This is called a training wheels example because I've done a lot of it for you. I've done the distribution. I've even drawn your boxes. We just have to do the drag and drop step. So first things first, we draw our line down the center. Distribution is already done. My boxes are already drawn.
Slow down, miss. Slow down. My eyes cannot handle it.
I drew a line. I start putting pieces where they belong. 16x comes over here. Oh, I want the x's on this side. That's habit. It's not wrong if you put them on the other side, but this is better. 16x comes right here. Bloop. The 10x crosses the center line, so what do I need to write down?
Negative.
Right on. All right, and then I come over for my everything else pieces. Bloop. 12 crosses the center line, negative 12. Do I need to change the sign of negative 6? No, because it did not cross the center line. Sweet. Now what do we do across the top? We add across the top. Always press the plus button in between your numbers. You might be adding negative numbers. That's okay. Always add. 16 plus negative 10 is 6x. Negative 12 plus negative 6, negative 18. And what am I going to divide both sides by? 6. Sweet. I heard a wait.
Wait, miss, how do you get adding to 16? Oh, wait, never mind. Okay, so in this one you subtract, this one you add?
Both of them are adding. So in your calculator, if you did 16 plus negative 10, you'd get 6. If you did negative 12 plus negative 6, you'd get negative 18.
You mean negative 10?
Yes, sorry.
I mean, the box method's okay.
I like it. It's easy.
So then we just have to do that calculations. Negative 18 divided by 6, negative 3. TBH, this is a part where people mess up a lot. Because you're gonna get this sometimes, and you will get fractions occasionally in my class. And then you're like, that's wrong, I should flip it over and then do that one because it's a whole number. No. If you physically write down divide by 6, actually type that part in your calculator. This is negative 18 divided by 6, which is negative 3. Okay? So trust what you've written down when you're doing these problems. Can I let you guys try the second training wheels example on your own?
Yes.
All right, go for it. All right, so if we're rolling through this one, okay, we've drawn our center line. The distribution is done. I've drawn your boxes. We start organizing our information. 5x. Bloop.
Negative.
Yeah, good. Bloop.
Positive.
I add across the top. I'm going to get 3x. And I'm going to get negative 1. And then what am I dividing by?
3x. How do you get?
Just by 3. Not by 3x, just by 3. And this is fine. This is the one that in particular I want you to make sure you've written this step down. Otherwise, you're going to try to flip it over in your brain. This is negative 1 divided by 3, which is going to give you 0.3 repeated, or negative 0.3 repeated in your calculator. But I like fractions. So if we change that to a fraction, negative 1/3.
Miss, I don't want to do that.
Miss, how do you get the...
The fraction?
Yeah.
So if you have your decimal answer, you're just... We have our decimal answer, go math. And then this is changed to fraction.
Can I
Press it. Boom. Okay, we're going to take some of the training wheels off. Not all of them yet, just some of them. I did not choose your boxes for you on this one, but I have done the distribution. So we have to ask ourselves those questions. How many pieces in this equation, boom, 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 have an X on them? 2, how many do not? Okay, sweet. That was part of the training wheels coming off. Now we just have to organize our information. Negative 5x comes over here. Bloop. This changes to 8x. Bloop. This changes to 10. And then 8 drags down. What do we do across the top? Add across the top. Negative 5x plus 8x is 3x. And 10 plus 8 is 18. Actually writing down the division step, what am I going to divide by? Divide by 3 for each side, which does give me 6 as my solution. If we plug that number into the equation and calculated it out, it would give me a true mathematical statement. Okay, you've got the next problem for yourself. There's more training wheels off of this one because I haven't done the distribution for you. You can do it. I want you guys to try this one.
Do I go for one of them?
Yes, please. Okay, I apologize if I'm cutting off your thinking, but I'm going to start going over this one. So before we can do anything with our boxes, we have to get rid of the distribution problems. So this has a 2 in front of parentheses. I'm going to go ahead and multiply that out before I try to do any sort of box stuff. 2 times x is 2x. 2 times negative 10 is negative 20. And then I write everything else down. Probably with better handwriting than that. But this is the distribution step. If we don't write this down, sometimes we miss our numbers. So make sure you're doing that recommendation. Okay, how many terms have an x in them? 2. How many do not? Sweet. Drag and drop. Here comes a 2x. And on this side, oh, I forgot my x next to 13. That's ugly. That's fine. And then 13x. And then my 20. Boop. Now it's positive. And the 10. What do I do across the top? Add. So there's 15x and then 30. And I'm dividing by 15. Actually write that step down so you know in your head or in your calculator what you're dividing what by. This is x equal to dos. See. Okay, we're going to do the first challenge question together, and then I'm going to give you the second challenge question on your own. But I'm going to make this first challenge question even harder. Can I do that?
No.
Yeah. We're going to change this from an equal sign to an inequality. We're going to change it to less than or equal to. Because I want to prove to you that this box method works for inequalities as well as equations. Because literally the only difference between inequalities and equations is that at the very end, if I divide by a negative or multiply by a negative number, what do I have to do with that sign? I have to flip it. That's literally the only change, and let me prove it to you. Okay? Now, I notice that there are numbers in front of parentheses, so I do have to do some distribution. 3 times x is 3x. 3 times x is negative 30. Then I write down everything else. This is a challenge question because I did not draw your boxes at all for you. So when they're not there, but we are solving an equation or an inequality, we can draw our boxes. How many pieces in this equation have an x attached to them? 2. How many do not? 3. So I'm actually going to make sure there's 3 top boxes on my everything else side. We drag and drop. 3 goes over here. Negative 5x, bloop, changes signs. Bloop, you're right. And both of the 17s get to just drop down. I heard someone say it already when we combined the everything else side. Yeah, we're going to get 64. And when I add this side, what am I going to get?
Are you sure they don't memory first?
What do I have to divide both sides by? 8. Do I need to flip my inequality sign? No, because I'm just dividing by a regular number. If I divide it by a negative number, that's when I flip it. So I leave it exactly the same, and I have x is less than or equal to 64 divided by 8, which is 8. And guys, this was the same steps. Literally, the only change can happen right here between equations and inequalities. It can be that last little flip of the sign. Otherwise, the steps are exactly the same, and now you have another method to do it.
Hold on. How did you get 3 numbers?
How did I get 3 numbers? There's 3 pieces right here. We have a 30, a 17, and a 17. So this side has 3 terms that don't have that.
This one gets the one with no x's, and this one gets the one with x's.
Yes, this side is always the stuff with x's. This side is everything else, but basically no x's. Okay, prove it to yourself that you know it. Try the next challenge question. I'm not going to make this one harder. It's going to stay an equal sign. Okay, try this challenge question on your own. Don't panic when you get your answer. Okay, so I apologize if I'm cutting you off from the time you're done, but I think majority of the class is ready. No. So draw our line, and then we multiply, which is our distribution step, so that we have 10x plus 8 equal to 5x plus 14 minus 3x. Okay, that's all I've done as a distribution step. That's the same as the other way. We would have done that first in our inverse operations. But now I draw myself 2 boxes so that I can just drag and drop to organize my information. Okay, how many pieces have an X on them? 3. How many pieces do not? 2. Okay, drag and drop. Good. Bloop. Change the sign. Bloop. Change the sign. Bloop. Change the sign. And that one's okay. What do we do across the top? We add across the top. 10 plus negative 5 plus 3 is 8x. Negative 8 plus 14 is 6. What am I dividing both sides by? 8. I heard a wait.
Oh, never mind.
Okay.
Wait. Huh?
I heard wait.
You told me 2 times 4 was 6. I told you it was 8.
Yeah, so we do 6 divided by 8 in our calculator. It's going to give you 0.75, but I want it as a fraction.
I said there's
3/4.
And the
3/4.
Yeah, whatever. Same thing.
Well, yeah, whatever, same thing. So yeah, 0.75 is fine, but I would rather have the fraction answer, but this is okay. All right. Yeah, go ahead and glue this in your spiral. If you want to glue it near the other solving equations notes we've taken at the beginning of the year, that's fine, or else just put it behind function notation. Your
Papers
notes.
haven't dried yet.